Hello, good morning to me. This is the final lesson in our first trig unit in the second half of PreCalc class. So we're going to talk about the multiple angle identities, double angle and half angle identities today. And your notes they're going to look really short, and mostly the reason for that is because half the identities weren't even put on that page. So sorry, my bad. The good news is they are on your reference sheet. This is a bit of a typo because it's from a previous year. I believe your reference sheet for our class this year in 2018, and I think it's a pink reference sheet. So make sure you have that next to you, and we're looking at worksheets 7A and B. 7B is it's an assignment that'll go over all the different identities that we've talked about in the last couple of lessons. So double angle identities. If you have sine of 2 theta, that can be swapped out for 2 times the cosine and sine of that initial singular angle theta. Tangent of 2 theta is this guy, but what we have here is sine 2 theta over cosine 2 theta. That's just another version of a trig trade that you can do for sine 2 theta, and depending on what our end goal is, what we're trying to do, you might want to have one swap versus the other. And you don't have to understand why they're the same at this point, guys, just trust me that they are the same. And then cosine 2 theta, how fun, you have 3 different options. So again, you want to kind of look at what you're trying to do. If you're trying to solve an equation, and you want to trade out for all sines, then you're going to want to use this formula. If you're trying to solve an equation and cancel out a term of sine squared, then you're going to want to use this one. So you have to think about what your end result is. And they're all different trades. You don't have to memorize them. They are on your sheets. So this question here, this screen, is just an example that's already been done for you. So we have sine of theta is negative 7 over 25, and they've gone ahead and drawn this in the coordinate plane with the appropriate triangle created, and then the r value is 25. The adjacent, or the x value, is 24, which I know it's not appropriate to do this, but I always call that negative 24 because it's going left. And then, again, sides of triangle are not negative, but I like to call it negative 7 because it's going down in the coordinate plane. So they told you which quadrant you were in. That's how we need to write it there. And then it says find the sine of 2 theta, and find the cosine of 2 theta, and then find the tangent of 2 theta. So we have 2 different methods that are shown here. This first method for finding tangent, excuse me. So sine 2 theta is the first thing they asked us to find, so I just use that formula. 2 times sine and cosine of the initial theta. So 2 times these 2 fractions gives you this amazing fraction. And then cosine 2 theta, it didn't matter which formula we went with, but whoever wrote this question went with the 2 cosine squared minus 1 formula for cosine 2 theta. And they plugged in the appropriate values and then a little bit of fraction work, and they got that fraction. And then for finding tangent 2 theta, this is them going through that really lovely fraction-looking formula where you 2 tan theta minus over 1 minus tan squared theta. And they get that answer. But remember how we had a secondary formula for tan 2 theta, and that was just taking sine 2 theta over cosine 2 theta because of the tangent ratio relationship. So since we already found sine 2 theta and cosine 2 theta, that probably would have been a little easier. So you have to think about, yes, you do have options, so you're going to want to do the one that's easiest for you. So this is what's on your paper. You don't have to write these down. They are on your notes, and they're also on your formula sheet. And this example is also on your notes, and it's not done for once, so let's go ahead and fill this in. So they told us what quadrant we're in, 0 to 90, or 0 to pi over 2, if we're looking at radians. They want us to fill in some info. Sine is 1 over 4. So doing a little Pythagorean theorem, that would be hypotenuse squared minus leg squared, so that would be the square root of 15 for my x value. Alright, so then the cosine of theta is square root of 15 over 4. And then if they want us to find sine of 2 theta, it might be helpful to notice that you can draw it. Now, you're assuming that I drew a triangle that was to scale, and maybe not. But sine 2 theta would just be twice the angle, so we're still going to be like up here, but it's still going to create a triangle. Now, by no means do you have to do any more math other than use your identity. It's 2 times the sine theta times the cosine theta. So you already knew sine from the original problem. Sine was 1/4. And we just found cosine, which is square root of 15 over 4. And if you do 2 times those 2 fractions, You have to be careful with your fraction work here. You got 2 times the square root of 15 in the numerator over 4 times 4, so 16 in the denominator, and then you're going to reduce those coefficients to 1 over 18. So that's how they're getting the answer of square root of 15 over 8. So, oh, bummer. That was done for you on your notes, I just noticed. I hate when that happens. Okay, this next one. This is not done for us. It says the tangent of theta is 4 over 3, and we're in the third quadrant because of this clue. Plus, someone already drew it for us, so that was nice. I know it's not technically appropriate to call triangle legs negative, but I'm going to do it anyways, and this is a 3, 4, 5, which I could have done Pythagorean theorem on, but either way, the r value is a 5. And they want me to find sine 2 theta, cosine 2 theta, and tangent 2 theta. And I like that shortcut where once you know sine 2 theta and cosine 2 theta, we can just use those to find tangent 2 theta. So, sine 2 theta. That would be 2 times the sine times the cosine. So, 2 times the sine, it doesn't matter what order we do this in, guys, but sine was negative 4 over 5, and cosine would be negative 3 over 5. And if I do a little fraction work here, let's see, I have negative, no positive, 24 over 25 for the sine 2 theta. Alright, similarly, we're going to find cosine 2 theta. I don't really have a favorite formula. I kind of like that cosine squared minus sine squared formula, so let's try that. So cosine squared would be 9 over 5, right? Negative 3 over 5. No, 25. Hello. Hello. 9 over 25. And then minus sine squared, which would be 16 over 25. And that would give me negative 7 over 25 for cosine 2 theta. And then for tangent 2 theta, which is covered up under here, I'm just going to take sine 2 theta and divide it by cosine 2 theta. So I know those. We just found those to be, what do we get? 24 25ths. And we're going to divide by a fraction, so I'm going to multiply by the reciprocal. 25s will cancel, and I get negative 24 over 7. That was for tangent 2 theta. Definitely not the only way to get cosine and tangent of 2 theta, but that's the way I went. If you think about drawing this, and you think about what quadrant you would end up in, this is kind of confusing, because like if we think about it in radians here, this is pi, right? And this is 3 pi over 2. So I know I'm at least bigger than double a pi, right? So I'm at least bigger than this guy, 2 pi. And then 3 pi over 2 doubled would be 3 pi. It's a confusing thought. So I'm somewhere between here and here, guys. But apparently, if you look at your signs here, sine is positive, cosine is negative, and tangent is negative. Apparently that angle ended up over here in quadrant 2 after the double rotation. So good to know. So what good are these trades unless we can use them to actually do something like solve an equation? So we saw earlier on a simpler equation solving section in the chapter where we had to make some trades. We couldn't solve something that they weren't in the like terms, they weren't, emulating a quadratic that I could factor, so we had to trade some things out. Cosines and sines together usually weren't great. I had to trade some Pythagorean theorem identities, so here we're going to start trading double angle identities. So this example is already done for you, but sine 2 theta, they went ahead and traded it out for 2 cosine times sine. And then they had a common factor of sine they could factor out of that expression, and then they could solve it just like we always did. So, nothing crazy happening there. We just keep trading. We have more things to trade. How fun. All right, power reducing identities. These are on your blue sheet, and they can also help us solve identities. The problem is they're not on your notes, but apparently we don't use them that often. I guess that's why they didn't make the cut for the notes, huh? But they are on your pink sheet. The other thing I might want to tell you, I think it's on your pink sheet, is if you were to square root both sides of these, you would get what we call the half angle identities, which I think are coming up on the next screen here. Yep, right here. So again, on your not blue but pink reference sheet, these are those power reducing identities. If you square rooted each of them, right? So I think, maybe not. I lied. No, they're not. They have no relation. Ignore me. All right, so there's a nice note here. My wonderful counterpart here. she forgot to put them on the notes, and then I forgot to double check the notes to make sure they were on the notes, and then this is what happened. So these are on your pink reference sheet. I think I skipped over a question, didn't I? So using the power reducing trades, they traded this guy here for this. What was it? I always forget that one. 1 plus cosine 2 theta over 2. And then it says to plan ahead which trade. Well, I'm thinking this is actually a good trade. If I can just get common denominators, that'd be amazing, no? So if I hit this fraction by a 2 over 2, and actually, forget that. I'm just going to get rid of the 2's. They all have denominators of 2's here. Plan ahead. Should have planned ahead. Alright, there we go. If I were to multiply everything here by a 2, I would end up with 1 plus cosine 2 theta, because the 2's canceled, minus 2 cosine 2 theta equals 1. And then combining my like terms right here, I get negative cosine of 2. I keep saying theta, it's x. Subtract 1 from both sides, I get 0. Dividing both sides by negative 1, I get cosine of 2x equals 0. And then remember double angles, you want to think about what this really is, right? And this isn't even like the only way you can answer this. So if you worked ahead of me or you're looking at another teacher's notes, you probably saw a different trade that they did. But remember, cosine 2 theta or 2x has a bunch of different trades. So I'm going to pick my favorite one. I like 2 cosine squared theta minus 1 the best, I guess. Okay. So solving this, I would add the 1, divide by 2. So I end up with cosine squared x equals 1/2. And then if I square root both sides, I want to know where the cosine is positive and negative square root of 2 over 2 when I rationalize. That's a lot of places. That's pi over 4. That's 3 pi over 4. It's 5 pi over 4 and 7 pi over 4. I'm sure there's a simpler way to write that, but I think that works for me. Alright, moving on. So back to the half angle identities. These are not on your notes, but they are on your pink reference sheet. Please notice the plus and minus in front of all the radicals. You have to think about like where you're located, whether your answer is going to be a positive or a negative radical. And basically what we're going to do is we're going to just kind of visualize it by drawing it out. So if I cut my angle in half, what quadrant would I be falling in? Trying to look ahead to make sure we're not going to hit anything weird. I don't think so. Alright, see this in action, huh? Oh, it does say, watch out, what signs, what quadrant are you in? Alright, good stuff. So, cosine of 22.5, or sorry, sine of 22.5, I don't know, but I know that this is 45 cut in half. So, if I use my half angle identity, which I never remember for sine, but sine is for the half angle. I'm going to steal it off of here. No, I'm not, because it's too small for me to read. I need bifocals. For now, we'll say plus and minus, but we'll talk about that in a second. 1 minus cosine over 2. Alright, square root. Okay, so think about whether you would have a positive or negative sign value. We're in quadrant 1, so we're going to have a positive sign value, so I'm just going to scrap that completely. Just say it's positive. And then, let's start, oh gross, this is going to be gross. Alright, 45. The good news is that's something we know off our unit circle, right? So the cosine at 45 degrees is what we're going to put right there, which I know is square root of 2 over 2. So I have the square root of 1 minus the square root of 2 over 2, that whole fraction divided by 2. Now, I don't know a math teacher in the world who would be happy with this as your final answer. So what I'm going to do first is I'm going to look at this numerator, and I'm going to collect it by using common denominators. I'm going to hit this by 2 over 2. So we end up with the square root of 2 minus square root of 2, all of that over 2, And then we still have a divide by 2. Well, remember guys, when you're dividing by a fraction, we can rewrite that. Oh, eraser. There we go. We can write that as a multiply by his reciprocal, which would be multiplied by 1/2. And this fraction, this radical, becomes the square root of 2 minus square root of 2 over 4. Now, I know for most kids, they don't really think that's an issue, and technically, mathematically, it's not awesome to have a radical within a radical. That's not what bothers me. What bothers me is the fact that you can square root a fraction by square rooting the numerator and denominator separately. So the best answer I can come up with here for pre-calc is square root of 2 minus square root of 2, and then that fraction over a simplified 2, because we square rooted the 4. Gross. Alright, so it's just a matter of like figuring out what formula you're supposed to be using and plugging in the appropriate ratios off your unit circle. Okay, I don't feel like thinking about radians right now, guys. Let's do 180 over pi and convert that. So the pi's will cancel. Oh gosh, be golly. Alright, let's see, that's a 2, and that would be a 30, and that would be a 330. So this is cosine of 330. Okay. I feel like I did something very wrong there. This is not my day. This, 6, 2, 33. I don't know, I should probably pause the video while I figure out what I screwed up here. I don't know, hold on. I can't even figure out where I screwed up, but this is not 330. It's 165. Oh, because it was divided by 2. I just realized what I did after I erased it. Okay. So I had 330. I forgot. Remember, I made that a 2. I forgot to divide that by 2. So it's cosine of 165, which happens to be 330 divided by 2. So if we're using our cosine half-angle identity, I can use the 330 as my theta in that formula. So going back and finding the right formula for cosine, which this is how frequently I use these guys. I don't even know. The cosine half-angle identity is plus and minus square root 1 plus cosine over 2. And that's all in the radical. So before we go and determine what the ratios are, let's talk about our signs. So I think about what quadrant I would be in. Cosine of 165 would be up here, and cosine is negative in that quadrant. So I'm going to get rid of that and go like that. You're okay with that? Oh, I just feel like I'm not on a roll today here, guys. Alright. Let's talk. Cosine of, remember, we're using 330. So I think about 330 as being this guy down here. If I look at my unit circle, the cosine and sine ordered pair there are square root of 3 over 2, comma, negative 1/2. So the cosine is square root of 3 over 2 positive. So what we are doing is we're plugging that into this half-angle identity. So we have the square root of 1 plus, what did I just say, square root of 3 over 2. All of that being divided by 2. And then we're going to have the same issue with like common denominator business, right? So, you can get common denominators here by calling this 2 over 2. Oops, we have a negative in front, don't we? And then I'm going to cheat a little bit. I'm going to rewrite this as 2 plus square root of 3 over 2. And then instead of dividing by 2, I'm going to call it times 1/2. And we have that same issue of our radical having weird funky radicals within it, also a fraction. So the only thing I could possibly simplify easily is that the square root of 4 in that denominator becomes a 2. So good answer for us would be negative square root of 2 plus the square root of 3, all that over a 2. Gross, 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 gross. After all that work, I'm always paranoid I messed up, but looks like I did okay. Alright, move it along. Sorry. So we're solving an equation including a half-angle identity because, you know, who would even know how to approach this, right? So what they did is, it's kind of funky because they have cosine squared of a half-angle. So they traded out cosine for the half-angle using that formula, and then they threw the squared outside of it, which thus negates the plus and minus idea, because if you're squaring a negative or a positive, it's going to be positive. So they just got rid of that, basically. And if you're squaring a square root, you end up with 1 plus cosine over 2. The 2's will cancel, and you have 1 plus cosine equals sine squared. And then they used our old friend the Pythagorean trade, which is 1 minus cosine squared. And then basically they had a polynomial emulating trig equation where they brought everything to one side. It looked like a quadratic, so they went ahead and they factored out a cosine from here and here. And they left that negative there because they knew it would be disregarded in the algebra in the next step. So they went over on this problem right here. When they set this equal to 0, they added the 1 and divided by -1. And they got cosine equals -1, which is at pi. And then for the other one, remember they factored out a cosine. When is cosine 0? At pi over 2 and 3 pi over 2. So if they wanted all solutions between 0 and 2 pi, there they are listed. So really nothing any crazier than we've seen. We have more things to trade and think about. That's all. So here's another great question. Sine 2 theta, we have a new friend we can trade for that. Isn't that 2 sine cosine? So cosine theta, leave him alone for a minute. And we're going to trade this guy for 2 sine theta cosine theta. And it's a bit of a hot mess, right? So we have 2 cosine squared times sine squared. Now, the fact that the 2's there, let's just get rid of that. I have cosine squared times sine squared equals 0. So this is kind of weird because there's really no algebra for us to do. We already have a product. So when is cosine squared equals 0 is basically asking you when is cosine 0. And then this guy is asking you when sine is 0. And just on one rotation of the unit circle. So we're looking at the quadrancials, right? So 0, pi over 2, pi, and 3 pi over 2. And it does say not to include 2 pi in your solution. So we would just list out those four quadrancials. That was kind of a weird question, wasn't it? Alright, so this is actually going to be your homework. So what I'm going to do is I'm going to do this first problem with you because it's a nice summary of all the new identities that we just saw. They give us a clue. They say sine of alpha is -3/5 and that we're in the third quadrant. So if I fill in those clues, and again, I know it's not great to call a triangle leg negative, but I don't care. It helps me, otherwise I forget it's negative. If we're finding sine of 2 theta, and I think about what quadrant I would end up in, I'm not going to worry about that so much because the math is going to work out beautifully on its own, so that's good. So sine 2 theta is 2, remember, times the sine times the cosine of just theta, or alpha in our case. So the sine value, it doesn't really matter which one you do first for sine and cosine, but we have -3/5, and then we have a -4/5, which, yes, I should be able to do math in my head right now, guys, but I got a 24/25. I hope you did too. Alright, cosine 2 theta. For this one, remember we have like 3 different options, and I think my favorite is the cosine squared minus sine squared. So I'm going to use that formula. So cosine squared was 16/25. And then if we subtract sine squared, which is 9/25, and they already have common denominators, so that's lovely. And we end up with 7/25 positive. Okay. Tangent 2 theta, I'm just going to use that nifty little sine divided by cosine for the double angles. So if I take 24 I am assuming that I did this one right, by the way. Alright, 24/25. Instead of dividing by 7/25, I'm going to multiply by the reciprocal and get 24/7. Oops, hello, there we go. Alright, this half angle guy. Alright, so let's think about what quadrant we'd end up in if I halved the angle. So this is pi, right? And this is 3 pi over 2. So if I think about where I would end up, I'm no further beyond half of this, so pi over 2, which would be this guy. And then 3 pi over 2 would be 3 pi over 4. So I'm somewhere over here in quadrant 2, which means my sine, half of my sine would be positive. Cosine and tangent are going to be negative though, so I'm just going to mark those down so I don't forget that. Alright, and then using my new formulas here, I already know it's positive, so square root of, I never remember this one, guys, 1 minus cosine divided by 2. So, blah. Should have wrote smaller. Square root of 1 minus cosine, which will be negative 4/5. I'm going to go ahead and change that to a positive 4/5 divided by 2. So if I got a little common denominators here, this is 5 over 5, so that would be what, 9 over 5 times 1/2 instead of divide by 2, which gives me square root of 9 over 10. Ugh. Square root of 9 over 10. Square root of 9 is a 3, but then I gotta rationalize. Okay, so after a little bit of more manipulation here, guys, we get 3 square roots of 10 over 10. Hope you're okay with following my icky math there. Alright, and then cosine we decided was going to be negative, so I'm going to throw a negative in front of this radical. And the formula is it 1 plus sine? No, 1 plus, oh, shoot, 1 plus cosine over 2. That's an alpha, not a 2. So negative square root of 1 plus a negative 4/5 is 1 minus 4/5, right? So negative square root of 5/5 minus 4/5 is 1/5 times 1/2 instead of divide by 2. So I have negative square root of 1 over 10. Rationalizing and simplifying that baby, we get negative square root of 10 over 10. Maybe? And then half tangent. I don't know if I wrote this down anywhere because we haven't seen this yet. But it's on your formula sheet, but there's like a gazillion formulas for tangent again. So the one I'm going to use is the square root of we just do sine over cosine, right? Over this stuff. Trying to find the simplest one, guys. I'm hemming and hawing over this, and I probably shouldn't bother. Forget it. We'll do one of the easy ones that are listed. So I know it's negative. I don't know, guys. The easiest one I'm thinking is, this one. 1 minus cosine over 1 plus sine, because we already found all that. That's what I'm thinking of. Remember all that work when we did 1 minus cosine up here, and that was 9/5? So this is negative square root of 9/5 divided by 1 plus cosine. That's what we did here on this problem, so that was 1/5. And then if I revert this to a multiplication question, I have negative square root of 9 over 1, which is negative 3. Oh, that was lovely. I just thought of something. I could have just taken sine half divided by cosine half. Alright, forget me. Alright. There's a typo here, guys, so make sure you fix that. It's not supposed to say that. It's supposed to say X. It definitely doesn't say smiley face. So I'm going to leave these for you to have fun with. Some of these are going back to some old trick traits. The sum and difference formulas show up again. I like this worksheet because kind of just puts everything together. So apologies for my bumbling at the beginning. What's new? Good luck.